In number 6, we're trying to figure out, is this a right or an acute or obtuse triangle? And the way that we're doing that is by using the Pythagorean theorem and setting it up as if we know for sure that a squared plus b squared really is equal to c squared. But we don't know that for sure. And so if this side, a squared plus b squared, ends up being larger, instead of a right triangle, it'll be an acute triangle. And if this side, c squared, by itself ends up being the larger side, then it's obtuse. But if they really are equal, balanced out, then it's a right triangle. Okay, so let's plug in what we know. And the first thing we would need to do is identify the longest side, which kind of acts as our hypotenuse if it ends up being a right triangle. 15 is that longest side, so that'll be our c value, and we're going to square it. And we're going to set that equal, kind of, to the other two sides squared and add it together. So we'll call this our a side, so 5 times the square root of 5 squared. And then that'll be our b side, so we'll call that 10 squared. And we do some algebra to compare the sides and see if they really are balanced out, or if one side's larger than the other. Okay, 5 times the square root of 5 squared, that's like 5 squared, which is 25, times the square root of 5 squared, which is 5. Altogether, that's 125. That's supposed to be a 5. Plus 10 squared is 100. And then that's set equal to 15 squared, which is 225. Okay, altogether that really is 225, and that is really the same as, it's equal to 225. And since you've got both sides that are really equal, the Pythagorean theorem is true, and therefore this is a right triangle. Okay, and since this was our hypotenuse, that means our right angle would have been right here in that corner.